If a function is increasing, it's going up. So what does that mean about the first derivative? The first derivative is positive. So it means f prime of x is going to be greater than 0. If it's decreasing, the derivative would be, so therefore f prime of x would be less than 0. Look at our graph right here. First derivative, positive or negative? Right here. Here? Actually, I'm going to keep this on the top part, not the bottom part. So you can see that we have spots where our derivative is positive and spots where our derivative is negative. What's interesting about that is the first derivative also tells us about local maximums and local minimums. True or false, this function is a local maximum at approximately negative 2.7. True. So there's two things that we want to say about it there. What is the derivative of the local maximum? 0. So often what will happen local maximum, local min, this isn't all the time, but this is really a 99% of the time case scenario for what we're going to look at. F prime of x is equal to 0. But more importantly, this is, again, most of the time, this is not actually part of the definition of a local max or local min. What we really want to look at is f prime of x changes sign. So at a local maximum, it changes from positive to negative. At a local minimum, it changes from negative to, and as we see that, we can then state that there are local maximums and local minimums. So this one might be at, say, 0.7. So we are going to make these number line tests, and we will look at the first derivative. So from negative infinity to negative 2.7, is the first derivative positive or negative? It is positive. Between negative 2.7 and 0.7, is the derivative positive or negative? Negative. And from 0.7 to infinity, is the derivative positive or negative? So I can also learn something about a second derivative test. Second derivative test tells us about concavity. What is concavity? Concavity is kind of like whether or not you are going to be holding water in a cup or dumping water out of a cup. So looking at this part of the graph right here where my hand is, would I be holding water in a cup or dumping water out of a cup? Dumping it out, and that would be concave down. Here would I be holding water or dumping water? I'll be holding it, so therefore this would be concave up here, okay? Now that's a very poor definition because there's a point at which it changes from concave up to concave down. But the idea is this. In order to talk about the second derivative, this is where you're really going to have to think. And this is the toughest part you got to think through. Once you get through this, you're going to be fine. The second derivative is the rate of change of the first derivative. The second derivative is the derivative of the derivative, right? So I have to look at the change of the derivative. I will represent the derivative by drawing tangent lines. Is the derivative positive or negative? If you want, is the derivative positive or negative? Is the derivative positive or negative? Okay. We already knew that the derivative was positive, correct? But let's think about the second derivative. The second derivative is the rate of change of the first derivative. Tell me, is the first derivative becoming greater in value or less in value? Why is it becoming less in value? The slope is becoming less, right? Here it's really positive, and here it's going towards 0, correct? You tell me the point at which, I mean, it's still becoming more negative, right? You tell me when I get to a point where the derivative, the second derivative, stops being negative. So when the tip of this line, instead of dropping down, it starts to actually pull back up. You tell me when you think that I'm at that spot. Okay, same thing as second hour. We missed the spot. Okay, we're actually a little bit before that. Okay, if you notice, it's continuing to get negative. But after this spot, doesn't it start to pull back up? You see how it's dropping, dropping, dropping. But now it's pulling back up, right? And so that happens right about here, where it stops dropping down and it starts pulling back up. And that's what we call our point of inflection. Okay? You don't like that? Okay. Might have to rewatch or think about it for a while, but that's exactly what happens. That's the way I kind of describe it. But as you watch again, the tips of these lines, it's dropping down as I move along more and more and more. It's starting to drop, drop, and then all of a sudden, when I get to here, all of a sudden my lines start to pull back up and start to increase. No, that's approximately. I mean, anywhere in that area would be pretty accurate. Right here. Okay, excellent question. Would you agree that this is continuing to drop? Okay, watch here. I'm going to draw a tangent line. This is my first one. Whoop. This is my first one. This is my second one. This is my third one. What has the most negative value? 1, 2, or 3? 1. See how already at this spot it's starting to pull up further? I mean, finally at 3 it's 0, right? But it's starting to pull up even before it gets to the bottom. Okay, this is my last shot. Yep, we'll get to that in a second. Okay, so the slope right here might say be positive 1. The slope right here might be say 1/2. Slope here might be 0. You guys okay with that? Here it might be negative 1/2, and here it might be negative 1. Right? But then here, negative 1/2. Here, 0. Here, 1/2. Here, 1. So you can see, are the numbers getting bigger or smaller? And that's as small as they get, right? And then they start to get bigger. It's an estimation. It's positive, right? I'm saying the derivative. Okay, better. All right, so concave up happens to be where f double prime of x is greater than 0. Concave down happens when f double prime of x is less than 0. And a point of inflection happens when f double prime of x changes sign. That's also when f double prime of x is equal to 0, most of the time. Okay, last piece. Let's tie in local max and local min now to our second derivative test. If it's a local maximum, you tell me, is it concave up or concave down? Concave down. So a maximum happens when f double prime of x is negative. Furthermore, look at what's happening to the first derivative at the maximum. Is the first derivative positive or negative here? So the first derivative changes from what to what? Yep, f prime of x changes from positive to negative. Yep. A local min, is it concave up or concave down, a local min? Concave up, so that means f double prime of x is greater than 0. Look at the first derivative at that spot. First derivative changes from, yes. Okay, flip it over and let's at least try to start one example. It says for the following functions, identify intervals of increasing, decreasing, concave up, concave down. So we'll start with increasing and decreasing. Do I do the first derivative test or second derivative test for increasing, decreasing? First derivative. What is the first derivative of this function? So therefore, -2 and 2 are my critical points. That's where something interesting happens. What I will do now is I will test. And I will test by plugging in values. What is a value to the left of -2 you can plug in? Plug in -3. What is -3 minus 2? So it is negative, right? And -3 plus 2 will be a negative. A negative times a negative is a. So the first derivative is positive from -infinity to -2. What's a value between -2 and 2 that I can plug in? 0. 0 minus 2 is negative. 0 plus 2 is positive. A negative times a positive is a. Yep. Last year, we did something called tables and graphs interval testing for inequalities that were nonlinear. And so we're dealing with a nonlinear inequality. So that's what we're doing. Very good. Now I plug in 3. 3 minus 2, positive, positive. So therefore, you can see by our first derivative test that we are increasing over what interval? Union with, and we're decreasing from -2 to 2. No, because at -2 and 2, it's neither increasing nor decreasing. It is 0. Right, you will not include the point where it's equal to 0. So that's just one example. We need to also do local mins, maxes, inflection points, stuff like that. We did get through this example first hour. You guys had questions on your assignment, so we went through that. So we'll have to pick up speed. You don't have any assignment today, so I will do my best to A, find the answer key, and then B, get it uploaded online. I'll see what I can do there. So you guys have a great day.